All right, so first off, apologize for the terrible audio. It's late at night and there's a lot of crickets in the background as I just recorded a video and had to thought I'd at least address that on this new one. So this is my template I decided, or my jig I decided to fab up. My first attempt at one, so don't kill me or harass me too bad. So what I got going on is the width of the car, or the suspension, is a little too wide. I mean, it fits underneath the fenders. I've got a little bit of room, but I'd like a little bit more. So the plan of attack here is I need to basically make new upper control arms. The lowers have plenty of metal in them. They're steel. I can cut an inch out of those, or inch. I'm going to go an inch and a quarter. I'm going to try to anyways. And I'm not seeing any issues with cutting an inch and a quarter out of the lowers. Plenty of room. The uppers, though, there's no way to just move these because all this stuff hits the upper spring perch. So what I've done is I've made this jig here. I've got the ball joint, the outer edge, not near the cup. I've got it tacked in place where I can cut off later. On the sides, what I got going on here is I've got a template I made that goes up and over here, so it's got a bolt through there. The outer is welded, the inner plates are not, so there's one on each side. Let's see, over there I guess would be a better one. All right, and so the plan of attack is I've already drawn up a basic template for this out of just some, and cut it out of just some thin sheet metal. I always cut out thin stuff first to make sure it's going to probably work. And so the plan of attack is that I'm going to cut one that looks more like this. That will, you can see that will give me plenty of extra room around the spring perch. And the plan is to cut this out on the plasma table with some 1/2 inch steel. So the plan is I'm going to cut it here and here. And then I'm going to take out my bolts, slide it forward. The outers, like I said, are welded in place, so the inners should not move. And I don't plan on taking out this main bolt that holds in, so it's just going to move the entire, the outer housing pieces forward. And then from here, we're going to cut this around here, get our template. I don't think I'm going to end up actually cutting this out. I'll show you, before I actually do it. But I think I'm going to kind of cut it off here and here, and then use all this. So I'm basically going to weld in what's here to the 1/2 inch, weld in the 1/2 inch here, plate it all in nice, and save a bunch of money that way. There are some aftermarket companies that sell these control arms. They're about $1,200 after shipping and stuff, give or take. And so right now I bought some steel, way too much than I need, for about $150. So I think I could do all of this for about $150. Get some new bushings, new ball joint, put it all together, and saving a lot of money and get where we need to be. So I'll show you the next step as I get cutting stuff out here in a little bit. So let's talk about when designs and things go wrong. So if I'm going to show you the build, I'm going to have to show you when things aren't so great, when I fail, essentially. So what I did is I wanted to make my own control arms. Well, the lowers on this car were steel, so I cut out 1 inch and narrowed the control arms 1 inch. Actually slightly over 1 inch. I then wanted to make my own uppers. So what I did is I cut out some 1/2 inch plate, very similar to the Michigan Metalwork control arms that are on my panel truck. And I basically just came up with my own shape and design and cut those out. Now you see I just have a hole here for the ball joint, the upper ball joint. Essentially, it's the same as a factory control arm with a hole. Now the factory one has a taper to it. And basically what I thought would happen is, because there is a flare or a flange on this upper ball joint, I thought that once I put it down through there, knocked it in, I made it tight enough to where I had to actually, knock it down into the hole. And then I thought once I put it down through the spindle and then tightened everything up, everything would be sandwiched and nothing could go anywhere. Well, as you see here, as I just showed a second ago, that didn't happen. This ball joint popped up out of my control arm. So that's not good. Severely back here. If we were on the road, this is disastrous. By the way, these are just there for mock-up. They look bad, but there we go. So this would be obviously very bad if this happened down the road, especially if you're loaded down with your family and that kind of thing. The other thing I don't really love, and I know this is going to be probably a problem anyways, is that I get a lot of negative camber when it's laid out. That is kind of what it is. Unfortunately, I don't really love it, but my solution was, well, hey, I'm going to throw on, for now, I'm going to throw on a factory upper control arm and see if that changes everything. So on this side, I threw a factory upper control arm on. I had to do a little trimming on the inside there, just on the flange so it'd clear. But I ran into other problems. One, obviously, since the lower is cut down a little over an inch and the factory is longer, it's going to throw the geometry all off. One, that helped out with my camber. Now, I'm using a GoPro, and I don't have it like aligned, so it still shows some camber, which is fine with me because that's laid out. The problem is I can only lift the car up about an inch at the most before I basically get zero camber, and then anything above that, I get positive camber. So that is not going to work either. What I mean by camber is, obviously for car people know this stuff, but it's basically the tilt of the wheel or the tire. So essentially, right now we're at negative camber, leaned in, at positive, we're straight up and down, and then zero camber, straight up and down, and then positive camber, we go at an angle. The other thing is, if you look at the ball joint angle, if I can get in here and show you, it is pretty severe. That is not going to work out either. And if you notice, look, it actually popped the ball joint out of this factory cup. It is also close to the rim, but it is not touching. So we're good there on clearance, especially once you lift it up, it adds more room. But this isn't going to work either. The problem I have with that is that I started to cut down, just for the fun of it, to cut down a factory control arm, basically pie cut the sides of it and then bend it down, and then that way I was going to re-weld it and then check to see if that helps. One, that will change the angle of the ball joint when it's laid out, and that might be a simple solution for something I kind of need, but I also am too long. So what I did for now, and I still have to test fit it and try it out, is I took the control arm that was off this passenger side, the one that I originally made, powder coated, had to grind through all my powder coat, and I basically just cut it and then turned it down and then changed the angle to where we are now when we're at a different angle for when it's going to be laid out. That should help. But I think we're going to have to go back to the drawing board. I think no matter what, I'm going to have to make a new upper control arm. I don't think, even if this were to work out, I don't think it is the best way to go. Besides like welding this little flange to the control arm, which would not make the ball joint serviceable at that point. You'd have to cut it out, which would be annoying. I don't really know if this is the right route to go. I thought that it would all sandwich down, everything would be nice and tight, and we'd be good to go, but second guessing that. I don't think I want to take my chances on a ball joint that can just pop up out of a cup. So besides finding an alternative that bolts in, we're going to go back to the drawing board, which I will show you here in just a second. Over on my table, the next plan of attack. Now I am still probably going to fit this guy just to see what happens when I lay it out, and also to see if that angle helps me out, and so I can basically use this one as kind of a R&D to find out on the next ones I go to make if I have to obviously add in some type of adjustment on that ball joint. That angle is going to be too severe if I stay with a straight, flat kind of factory style. So it's going to have some type of kick down to help out with the angle, because that is just too severe and will cause premature failure. So here we go. We'll go to the table and I'll show you what the kind of plan of attack is from here. So over here on my table, the next potential option we have is a bearing and cup setup. So what I found out is if you go to look at a factory Crown Vic ball joint, you notice there's no taper there. Unlike a, let me get you across here. Oops, sorry. Unlike a C10, if you see that there, we have a taper on there. So we basically just have a straight, basically a bolt. So what we got going on is, here's some part numbers for you. We have a bearing, a COM 12T bearing, a 12P or a CP12 cup, and then a high misalignment joint. So what we got is a bearing, okay, a spherical bearing, okay. Then we have a cup that has a ring in it for a C-clip, and then we have a high misalignment joint. So if we put this guy in here, which is a very tight fit, it doesn't actually even slide down there. I'm probably going to have to knock it in, and then we can clip it in. We could then just run a bolt, and we could basically replace the whole upper ball joint itself. So this is potentially the new plan. Most likely I'm going to try to make something work with this whole setup into a new upper control arm and see if that works. I'm going to first put on the other control arm that I cut down and change the angle on to see if that fixes the problem. But I think this could be the next best solution, because assuming I can get enough angle out of this, once it's all together, basically with a bolt going through, and then on the bottom side we'll have to run the taper of there's a tapered washer essentially on the Crown Vic, so that way it fits on the spindle. So assuming worst case scenario, we may go to this anyways, just because it might be safer. The idea that this guy can just pop up out of this race is not really sitting well with me. So if you see here, you can see how it's just a flange that goes around and then is pressed down into there. If we go with this method here, this route, once it's all assembled and the bolt goes down through there and it's tightened down, besides basically a bolt failure, we can't come apart, and it can't pop out of anything. You know, the head of the bolt will be down through here, and then this will all be sandwiched together nice and tight, and so basically nothing can go anywhere. So I kind of like this idea anyway, just for safety. So we'll stay tuned and we'll see what we come up with. So that's where I'm at. Sometimes things don't go as planned, and you have to course correct and try again. You know, that's all part of doing this stuff out of your garage and not buying expensive bolt-on parts. You know, it's win some, lose some. So update, I threw the control arm on there that I modified the angle. So if you look at the angle, you see that it actually kicks down. The ball joint is tight, and as you see, the ball joint is in flat against the control arm. And then we got going on here is we got some air in it, and this is basically ride height. If you see, we got the tie rod is basically parallel with the rack is what I wanted. So we're just under about 3 3/4 inch ride height, which sounds pretty low, but that's about your standard car these days. Plus I wanted this thing to be pretty much hammered, so it should be good. And then when we lay it out, here we go. Sorry, you're gonna get some air noise. Besides a little bit of the spindle touching the upper arm there, you see that the ball joint is at a better angle, and it stayed in the control arm. So I think that is the main thing we got to fix on the other one. Also, I did notice on another control arm design, they basically put a cap over top of this with some bolts that went down through it in order to prevent this from lifting up. So may end up having to do a redesign of that and then incorporate something like that. But overall, much happier. Probably take a little bit off the spindle. There's some extra material there, so take a little bit off the spindle, take a little bit off the center, the upper bag or extra upper spring pocket, and that would be good to go. Overall, I think that's the ticket. So that's kind of a good relief to see. So we'll continue on. So since I took an inch out of the lower control arms and made those new uppers, I needed to modify the inner tie rods. I choose to always mess with the inner tie rods. So this is a factory inner tie rod. What you see I did is I cut it. I went back behind the little groove where the boot clips on. I went back an inch, and then I took an inch and a quarter out. So I took a little bit extra out. Here's what I took out of it. So you can see the difference in the length of the two. So what I do when I do that is I cut it, I bevel the edges real nice. I do a pass with the TIG welder, go around, and then I clean up the welds, and then I always slide a cap over the weld and then weld both sides of that. Therefore, ideally, it should be just as strong, if not stronger, than it was factory. You could argue that that's maybe not the safest way to do this kind of thing, but I always make sure I put a cap over it. Just welding it, to me, it doesn't seem safe enough, especially if taking the family out for cruises and that kind of thing. It's an inner tie rod to me. I used a brand new one. I didn't cut up an old one that's kind of sloppy. So, once again, like I said, you can make the argument that maybe this isn't the safest route to go, but like I said, I did put a nice bevel on it, get a good penetrating weld, and then cap over it with this other piece of tubing here. So if, you know, my kind of thought is that if somehow I damage or bend this, I don't think this is not going to be the failure point on the car, in my opinion. And if it is, then we've already hit something else, and it's already a really bad day, regardless of doing this mod. So that's what I'm doing for the to control the track width of the thing. So already done that. There's the second one. The other one's already on the car. So we'll get it installed. Thanks. All right, so here's how the car kind of turned out so far. I got the fender trim. Now the gaps are not, I didn't set the panel gaps or anything. I just kind of put the fender back on it. The goal was for the car to lay frame, and we're there. I don't know, light-wise if we can see, but we are laying frame from firewall back to the rear suspension, so we're good there. Overall, I think the car turned out pretty cool. Like I said, in the next video, you'll see what's going to happen with the car next. But suspension-wise, the control arms modified. Unfortunately, I put the fenders back on before I could actually show an updated video of the cups and the balls that I welded into those control arms I made. Got the LS mounted. We got the steering sorted. We're running a LS3 style manifold. Those worked best with this situation. I tried a couple different other headers, and these ones seem to clear the best. So, you know, we're good now. See, we got a lot more fender clearance with the control arms we made, and she's pretty low on the frame. So that's how she kind of turned out. Interior wise, still need to finish some stuff up, but sorry, the reflection, I guess I could open the door, but back seat was modified, recovered to go over the trans tunnel, or the drive shaft tunnel, so we're good to go there. So stick around for the next video, and I'll kind of explain what's happening with the car. So there she be.